Okay, let's look at a detail that we need to be careful with when it comes to the power rule. Look right now at examples A and B. Look at how they're similar and look how they're different. They all have the exact same numbers, okay, but B has some parentheses that make a big difference. So let's look at A. The way that A is written, we just did something like this. We need to move that x cubed out of the denominator by using negative exponents. The 2 stays in the denominator. Stays in the denominator. I feel like my blood pressure rises every time I have to preach about this. Okay, so let's apply our power rule. Bring down the exponent, multiply by the coefficient in front, subtract 1 from your exponent, and let's simplify. So we've got negative 15 on top, and we've got 2 with an x to the 4th in the bottom. I went ahead and got rid of the negative exponent and moved it to the bottom. Now, B, we got to be careful with this, okay? We really need to apply that exponent first before we do anything else. So we are going to apply that power of 3. So 2 cubed is 8, and x cubed is, of course, x cubed. And then we need to put it in a form where we can use our power rule. So dy over dx is equal to, bring down the exponent, multiply by the coefficient that was in front, subtract 1 from the exponent. So very similar, we've still got negative 15 on the top, but this time it's 8x to the 4th on the bottom. Those parentheses really, really matter, and we've got to apply the parentheses before we can do anything else. Okay, let's look at C and D. Again, same scenario, but I threw a negative exponent in there to start with, and it's in the denominator. So let's get rid of it, but this time when we move it, it becomes positive because it was already negative in the bottom, so when we move it, it becomes positive in the numerator. So f prime of x, the derivative of f, is equal to, bring down the exponent, multiply by the constant in front, subtract 1 from the exponent. So when we clean it up, we have 14x over 3. I'm not going to move that back to the denominator. Even though in the original problem it was in the denominator, I'm going to leave it there unless the answer choices are just bizarre and they do have negative exponents. Okay, I doubt they're going to. This is really just for my teaching purposes here. Okay, you're probably not going to run into a problem like this. Now, on D here, I'm going to do something a little bit different than I did in B, just because I'm not really sure about applying that negative exponent. So why don't we go ahead and we can move that entire expression this time because the entire expression is in parentheses with that negative 2 exponent. So move the entire expression. Now, we do need to apply that exponent before we can proceed. 3 squared is 9, x squared is x squared. Okay, so really we've got 63x squared. So let's apply our power rule. So f prime of x is equal to, bring down the exponent, multiply by the coefficient in front, subtract 1 from the exponent. So when we clean it up, that's what, 126x? Okay, so very slight difference. Just that introduction of parentheses makes a huge difference in our answers here. So you've got to be very aware of parentheses and where they are in a problem. So try out a few problems. These problems ask you to rewrite the expression before you take the derivative. So that's kind of what we were doing here with the negative exponents, with the parentheses. You got to rewrite them so that you can apply the power rule first.